properties of exponents. Now we're going to start very simple. We're going to talk about the 5 rules. And we're going to practice very simple. Then we're going to go to a more difficult practice, okay? Because obviously we've leveled up in here. So we're not going to have as many of the simple examples. We're going to have the more challenging ones. But we got to start small. When you're trying to understand math, especially if y'all go to college, like to higher level math classes, I've got one former student who's at Georgia Tech, and she's messaged me. She's like, "I need help. I'm in calculus." And my biggest advice is always start small. Small, simple examples with numbers that you understand or concepts that are small. Because if you can wrap your mind around a small concept, then you can apply it to the larger, more challenging problems. Because it's the same. All right, so let's start simple. 7 cubed. What does that mean? It means 7 times 7 times 7, right? Vocab here would be that 7 is called the base and 3 is called the exponent. Another vocab word for an exponent is called power. It's the power. Now, here is the very technical college level definition. Ready? We'll write it in 2 ways. Yep. Okay. Let me explain what this is. What does it look like? It looks like an upside down capital A. That's because that's what it is. It's an upside down capital A. That symbol is shorthand for any. For any, which means any. Like for any number that you plug into A and B, as long as it's not what? This is how you read it. As long as it's not 0, can't be 0. That's how you read this. So, for any number you pick to plug into A and B in the following formulas, as long as you don't pick 0, and then for any, what type of number? This was any number, but this has got a restriction on it. This is only picking from integers. So for any integer you pick can be plugged into M and N, into these formulas, then these are the properties that exist. I'm going to let you write them down, and then I'm going to explain the properties. Guys, you already know this. You've just never seen it written in the college level context. We don't use the for any symbol very much. I just like to use it every now and then because you may see it in higher math classes, so why not go ahead and just kind of expose you to it now. If you don't like the symbol for any, then just write the words for any. But that's a fancy way of saying, hey, pick a number, any number, doesn't matter. And then there is a rule. It can't be 0. And then for M and N, pick any number as long as it comes from the integer family. So we have three rules here. They are separated by commas. The comma is not part of the rule. The comma is just saying, okay, you know, like there's rule 1, there's rule 2, and then there's rule 3. So don't let the comma throw you off. So looking at the first rule, this is saying for any number a raised to a 0, the value is 1. Y'all should know that. Any number raised to a 0 power is 1. Doesn't matter what the number is. It can be negative 4.875 repeated raised to 0. It's 1. It can even be pi raised to 0. It's still 1. Here's how you remember this. 1, you could use your calculator. Or 2, you could say to yourself, if I have, say, 3 to the 0 power, this means write 3 0 times. Because like up here we said 7 cubed. I wrote 7 how many times? 3. So write 3 0 times, which means I'm not going to write it at all. Yes? But the answer is not just nothing. The answer is there's an understood 1 there. Okay, so that's how you remember it without having to use your calculator. No shame in using your calculator to confirm. This you already know. This is saying that if you have any number raised to a negative power, the negative is not actual value. The negative is saying, hey, take the base and the power and move it to the opposite position of the understood fraction. Like this was not a fraction, but what's understood right here? The 1 on the bottom. So you're going to take the a to the m and you're going to move it to the bottom. Let's make a little extra note right here. Underneath it. The negative power has no value, semicolon. It means move the base and power to the opposite position. You do move whatever the negative power is attached to. We will get to some more complicated problems where you have to look at it carefully because the negative power, it might be attached to just one base, you know, like one number, but there might be a coefficient there as well that you have to make sure to pay attention to because you don't move the coefficient. Let me give you an example. Let's say we had 3 parentheses, 4 raised to -2. Okay, so let's say you had that, and if I said to clean this up, that means get rid of negative exponents. You have to look at it carefully. That -2 is only attached to the 4. So don't move the 3 just because it's there. Don't move it. So that would, 3 would stay on top, and I'd end up with 4 squared on bottom. Once you move it, you drop the negative. Because the negative is there to say, hey, move this. And then the negative is gone. Just pay attention to what it's actually attached to. That's what moves. Okay? Now, the next rule is, what if you have multiple negative exponents? Then you can move multiple things. You can be as simple as saying, hey, wait, these are both negative, so I'm just going to take this crap and switch it. That's one way to do it. If it bothers you to combine movements, then just break it apart and be like, okay, so a to the m, copy that, a to the m is going to go to the bottom, become positive. That leaves a 1 on top now because there's nothing there. And then you say, okay, b to the negative n's got to go to the get to the answer. So you can move it in one movement, or you can move it in, break it into two movements, whatever you're comfortable with. But that can happen. Okay? These rules you already know. You've just never seen the fancy notation. Now let's look at the 5 rules you also know. We're going to refresh you. I'm going to order to see. 5. So I'm going to change. If I write like this with it slightly thinner, can y'all read that? Everybody on the back row, can you read that? All right. We have the product rule. We have the quotient rule. We have the power rule. Probably should write this one down. Raising a product to a power. So we got 5 rules. I'm going to give you the formal definition right here in the middle, and then I'm going to give you an example over here to the side. Okay? So we're going to have the definition in the middle. And the definitions are always with just letters, which is sometimes hard for people to understand. They want numbers. So after the definition, I'll give it to you in numbers. So here's the definition. Power rule, you've got A to the M times A to the middle is going to be the formal definition, and then I'll give you an example of what it looks like with numbers. So A to the M times A to the N. You have to be careful when you say this. So if I have a base and a power times a base and a power, what do you notice about the bases? The bases are the same. They do have to match. If the bases match, you can write it as one base, and then the rule when you are multiplying bases that are alike with powers is you add the exponents. You add the exponents. You already know this. I'll show you a way to remember it too. So here's an example. I think I did 2 cubed. No, I did x. Okay. This is an example. X squared times x cubed. X squared times x cubed. Don't overthink this. Don't let a fancy rule throw away all of the math knowledge you already have. Think to yourself, x squared is how many x's? There's 2. X cubed is how many x's? 3. So, how many x's are there? 5. Right? Your mind probably wants to say 6 because you see that you're multiplying. But you're multiplying the bases. You're not multiplying the powers. So, you might want to draw the little example underneath where I showed how many x's you have, and that'll help you remember if you get bogged down in a problem and you forget, am I supposed to multiply or add here? I don't remember. Then just write it out. That's called expanded form. Write it out in expanded form, and then remind yourself, oh yeah, just add them. Okay, next, quotient rule. Same concept, but we're dividing. if we have a to the m over a to the n, you have a fraction with like bases. Bases have to match. You can write it as one single base to a power, and the way you condense the exponents is subtraction. So think about it. If I'm multiplying the bases, that translates to adding the exponents. If I'm dividing the bases, that translates to subtracting the exponents. And then the fraction's gone. And the way to remember the subtraction is, you probably know where I'm going with this, the fraction bar. Hopefully that will remind you, like, oh, okay, subtract the exponents. There is one rule here, and that is, doesn't come up, but we're going to write it, and that is that a cannot be 0. There's always a rule when you're dealing with fractions, because if a was 0, then we wouldn't have a problem with the bottom of that fraction. So you have to state, a can't be 0. It's not going to be 0. Ours won't be 0. It's just knowing the rules there. You will notice the fraction disappeared when I wrote it in condensed form. Let's look at an example. I'm going to do 2 examples. So I'm going to write EX1, and I'm going to write EX2. So the first example, let me change that. I don't want to do 4. Let's do x to the 5th. Okay, so if I have x to the 5th over x squared, the bases match, so I could write it as one singular base to a power, and I'm just going to subtract the exponents. So 5 minus 2 is 3, and then my fraction's gone. Don't overthink that either. Write it in expanded form. X to the 5th over x squared. You see it now? Cancels. What's left? X cubed. Where is it? On top. So don't overthink it. What if x to the 5th was on bottom? Be 1 over. So it would still, same concept, still cancels. That's what example 2's purpose is to show you that sometimes it may be what starts where a higher power is in the bottom of the fraction. If you were to subtract this, like we did the last one, you would end up with x to the negative 3, right? If you did 2 minus 5, you get negative 3, which means going back to that previous slide, you have to take the x and the 3 and move it down. So this translates to 1 over, I'm running out of room, x to the 3rd. Here's an easy rule to remember so that you don't end up with negative exponents. Always subtract to the larger power. If you subtract to the larger power, you will not have any negative exponents, and then you don't have to do that step. So watch what I mean. Where's the higher power? It's in the bottom. Visualize this. Don't write it. I mean, you can if you want to, but think of it. Okay, so I got 2 on top, I got 5 on bottom. Oh, it's going to go to the bottom. That's where I'm going to have 3 of them left. But just say to yourself, okay, so this is going to come away down here, and then you can see, okay, x cubed, there's nothing left up here, so I write an understood 1. So that's the way that I do it. So then I don't have That's it. That's all the time I have. I'm just kidding. That's the way I do it, so I don't have any negative exponents. So subtract 2, the larger power, and then you're good. All right. What's next? Power rule. Here's the rule. If you have a base and a power raised to a power, you simplify this, you're going to love it, by multiplying the powers. You write it as one singular base, and you multiply the powers. Very easy way to remember this. What do parentheses mean in math when you have, like a coefficient and then something inside? What's it mean? It means multiply. There's your indication right there. Those are so close together, that means multiply those numbers, okay? If you forget, let's go to an example. Let's do x squared to the 5th power. So if we have x squared raised to the 5th power, visualize the expanded form. This means write x squared how many times? 5 times. So that's how you see, okay, so I got x squared, x squared, x squared, x squared, x squared, which means I have how many total? X's? I have 10. Visualize that expanded form. Now I'm going to show you another technique, and you may not like this. You may think that's stupid. That didn't help me. This is the way I remember. This is the way that I remember. These are the 2 hardest for people to remember, and then here's how I do it. The difference is this one has how many bases? 2. This one has how many bases? 1. How many strokes of your pencil does it take to write a plus sign? 2. You add them. How many strokes of a pencil does it take to write a multiplication sign? 1. Don't think of the X. We graduated from the X. We're in college. We're doing dots for multiplication. So this is how I remember. If I see the bases, multiple strokes of the pencil, which means I'm adding them, like plus, 2 strokes of the pencil. The other way I remember this is multiply is what I said earlier. When they're that close together with the parentheses separating them, then I know to multiply. Okay? If you forget that, then do the expanded form, and then you'll see the correct answer. And then you can see how to get there, whether you add or multiply. So that's the difference between them. This rule, you see the bases. This rule, you have 1 base every time. Okay. Raising a product to a power. So that looks like this. You would have 2 numbers being multiplied together, raised to a single power. You should already know this. All you do is distribute the power to everything in the parentheses. It's every single thing in there is being raised to that power. So for example, if I had xy squared, that would be x squared y squared. And another way to think of that, I've said it multiple times, visualize the expanded form. This is xy times xy, right? So then you can see, okay, so x squared, y squared. This is the exact same concept, it's just if it's a fraction. two numbers in a fraction, or two values in a fraction being raised to a power, you still distribute the power to everything in the parentheses. So if I had x over y quantity, when I say quantity, I mean whole thing, squared, it would be x squared over y squared. Now we're going to practice 6 simple examples, then we'll go to your homework assignment. Everybody good with this? Almost. Nope, you need more? Yep, you're good. Are you sure? Okay. I'm going to write them first, and then I'm going to leave y'all to try them, and then we'll put the answers on the board. And the goal here is you're done when there's no negatives in the exponent, there's no zeros in the exponent, and any like bases have been condensed to a single base. That's when you're done, okay? And any powers are distributed. All right, so number 1, clean up. Okay, so here's the answers to those practice problems. Number 6, there's multiple ways you could do this. You could distribute the power, but it would be easier to take everything to the power and move it to the bottom, then distribute. The homework is the worksheet that I just gave you, and you technically can only go up to number 8. You could do the rest if you wanted to, but I haven't gone over the notes for it.